The next question, for a first order reaction, the ratio of time for 99.9% completion of reaction to half-life of a reaction is A2, B4, C10 and D8. The reaction is of first order. For a first order reaction, the expression for rate constant is K is equal to 2.303 by T into log of A by A minus X to the base 10. Here, A is the initial concentration, X is the amount that has reacted in time T, and A minus X is the amount unreacted in time T. So here, if we take A as 100, then X is equal to 99.9 and A minus X is equal to 1. Substituting these values in the expression, K is equal to 2.303 by T 99.9 into log of 100 by 0.1. Log of 100 by 0.1 is log 1000 and log 1000 is 3. Therefore, K is equal to 2.303 by T 99.9 into 3, or this would be equal to 6.909 by T 99.9. That is, T 99.9% will be equal to 6.909 by K. For a first order reaction, T half is equal to 0.693 by K. When we compare these two expressions, we find that T 99.9 is 10 times T half, and therefore the answer is C, that is 10. Coming to the next question, a radioactive isotope having a half-life period of 3 days was received after 12 days. It was found that there were 3 grams of isotopes in the container. The initial amount of isotope when packed was, the options are 36 grams, 48 grams, 12 grams and 24 grams. Students, you need to know that radioactive disintegration is a first order reaction. Whatever expressions we have for a first order reaction holds good for a radioactive disintegration reaction. Now here we have to find out the initial amount. The half-life period is 3 days. We need to know as to what was the initial amount when the radioactive isotope received after 12 days was only 3 grams. One must note here is, supposing the initial amount is X, in the first half-life period, it becomes half of X. In the next half-life period, it becomes half of this, that is 1/4 or 1 by 2 squared X. Extending the same logic, after 3 half-life periods, the amount left behind will be 1 by 2 power 3 into X. And after 4 half-life periods, it will be 1 by 2 to the power 4 into X and so on. So now, in this particular problem, what is the amount that was received? It is 3 grams. What is the half-life period? It is 3 days. And what is the time period after which the radioactive isotope was received? It is 12 days. In 12 days, you have 4 half-life periods. So now, during 4 half-life periods, what will happen is, the amount left behind will be equal to the initial amount divided by 2 to the power n, where n is the number of half-life periods in the given time. In this case, the given time is 12 days, half-life period is 3 days, therefore the value of n will be 4, and hence the amount in the container 3 is equal to initial amount divided by 2 to the power 4, or the initial amount will be equal to 3 into 16, and that is equal to 48 grams. And therefore, the right answer for this question is 48 grams. Temperature is one of the factors which affects the rate of a reaction, and it is found that in case of most of the reactions, when the temperature is increased, the rate of the reaction increases. It is also found experimentally that when the temperature of a reaction is increased by 10 degrees centigrade, the rate of the reaction gets doubled. For every 10 degrees centigrade rise in temperature, the rate of the reaction gets doubled. This leads us to the concept of temperature coefficient of a reaction. And temperature coefficient of a reaction is the ratio of the rate constant of a reaction at 10 degrees higher temperature to the rate of the reaction at a given temperature. The velocity of the chemical reaction doubles for every 10 degrees centigrade rise of temperature. If the temperature is raised by 50 degrees centigrade, the velocity of reaction increases nearly by dash times. The options are 10, 20, 30 and 50. Now, for every 10 degrees centigrade, the rate of the reaction and the rate constant of the reaction increases by 2 times in most of the reactions. For 10 degrees centigrade rise in temperature, it is 2 power 1. For 20 degrees centigrade rise in temperature, it is 2 power 2. For 30, 2 power 3 and so on. In general, for T degree centigrade rise in temperature, the rate of the reaction increases by 2 to the power n times, where n is the temperature, rise in temperature divided by 10. In this particular question, the temperature rise is 50. So, the value of n will be 50 by 10, which is equal to 5. As mentioned in the question, for every 10 degrees centigrade rise of temperature, the rate of the reaction gets doubled. Therefore, for 50 degrees centigrade rise in temperature, the rate of the reaction increases by 2 to the power 5 times. And 2 to the power 5 is 32, which means that the right answer for this question is nearly 30. Therefore, C is the right option. Coming to the next question, the experimental data of the reaction A plus B giving C plus D is given below. Experiment 1, concentration of A 0.1, concentration of B 0.1, the initial rate 5 into 10 power minus 3 mole per dm cube per minute. Experiment 2, concentration of A 0.2, concentration of B 0.1 molar, and the initial rate 2 into 10 power minus 2 molar per minute. Experiment number 3, concentration of A 0.2, concentration of B 0.3 and the initial rate 6 into 10 power minus 2 mole per dm cube per minute. The order with respect to A and B and overall order respectively, the options are A 2, 2, 4, B 1, 2, 3, C 2, 1, 3 and D 1, 1, 2. Students, please note that there are different ways of determination of order of the reaction. And in one of the methods, you have to keep the concentration of one of the reactants constant, vary the concentration of the other reactant and find out as to what happens to the rate. Then you can think of a relationship between variation in concentration of that reactant and the rate of the reaction, which will give the order of the reaction with respect to that reactant. Next step, you can keep the concentration of say B constant and vary that of A. Finally, you have to set up the experimentally determined rate equation. Let us say the rate equation is of the form rate is equal to K into concentration of A to the power M into concentration of B to the power N, where M is the order of the reaction with respect to A, N is the order of the reaction with respect to B, and overall order of the reaction is m plus n. So how do we determine m, n and m plus n for this reaction? See, initially when the concentration of B is 0.1 in experiment 1, and in experiment 2 also it is 0.1, which means that concentration of B is kept constant. Concentration of A, which was 0.1 in experiment 1, has become 0.2, which means that the concentration of A is doubled. When the concentration of A is doubled, it is found that the rate of the reaction, which was 5 into 10 to the power minus 3, has become 2 into 10 to the power minus 2, which means it has increased by 4 times. When concentration of A is doubled, the rate has increased by 4 times, implies that the value of m is 2. Now coming to the order of the reaction with respect to, say, B, what we find is that in experiment 2 and 3, the concentration of A is kept as 0.2. The concentration of B is increased from 0.1 to 0.3. That means it has been tripled. In experiment 2 and 3, the concentration of A is kept constant, but the concentration of B is increased from 0.1 to 0.3, which means that the concentration of B is tripled. And when the concentration of B is tripled, the rate of the reaction also gets tripled, which implies that the order of the reaction with respect to B is 1. And therefore, this particular reaction is of order 2 with respect to A, order 1 with respect to B, and the overall order of the reaction, as we all know, is the sum of the powers to which the concentration terms are raised in the experimentally determined rate equation. And in this case, m is 2, n is 1, and therefore m plus n is 3. And hence, the right answer for this particular question is 2, 1 and 3. That is, C is the right answer. Dear students, so far I have solved a few questions and explained the concepts required for solving those questions. I hope this episode will be useful to you. Please be confident, prepare properly, keep cool, face the exams confidently and score as many marks as possible. From my side, I am R. Vinay Kumar, Principal, KLE College, Bangalore. I wish you all the best. God bless you.